Hello. Right, here we go. We're going to do a few lessons now on shapes. And the first one we're going to do is work out perimeters of shapes. And we're going to do square sort of shapes, rectangle shapes, and triangular shapes. And perimeter is all the way around the shape. All the way around the shape. Um, let's see. Uh, if you're lucky enough to have a garden, to find the perimeter of the garden, it would be perhaps the fence that goes all the way around, or a car park. You could walk all the way around the shape. So that's what we're going to do now. First of all, we'll do a square shape, because that should be the easiest one, yeah? Now, the thing with the square is well, it's supposed to be a square, all sides are the same. If they weren't, it would not be a square. So, 3 centimeters, we only need to label up one side because the other 3 sides are all going to be exactly the same. So it's 3 plus 3 plus 3 plus 3. Yeah, because that's going to be 3, that's going to be 3, that's going to be 3. Don't get into the habit of multiplying 3, 4 times. Stick with the adding because you'll get muddled up with areas at the beginning. So 3 and 3 and 3 and 3 and 3 and 3 are 12 centimeters. There's no squared or anything. It's just a measure of length all the way around. Yeah, a tad more complicated, but not too much. 10 meters and 3 meters. Now this is a rectangle where the opposite sides are the same size. So if that's 10, this will be 10 as well. And if that's 3, then this one on the left will be 3 as well. And we add them all up together. 3 plus 10 plus 3 plus 10, 10, 26 meters. Okay, so that's how to find perimeters on those basic shapes. And what we're going to look at is shapes that are a little bit more complicated than that. And sometimes they don't give you all the information that you need, and sometimes they will. By the time you get to your level 2 exam, then now do forgive me, I'm drawing this freehand, so all these are supposed to be the same, you know, parallel to each other and right angles and all this kind of thing. There's no wobbly lines there, no slopey lines either at the moment. So if we say that that's 8 meters and that's 5 meters, not to scale. Now you'll find this written on functional skills of all levels, of all exam boards and GCSEs and A level and all the rest of the stuff. It's so that you don't get your ruler out and start measuring things. They won't want you to do that. So sometimes they deliberately make things look like what they are not. So, and that's just basically my excuse because I can't draw accurately. So let's have a look at that. So we call that 10 meters. And we call this, I don't know, what's that? What do you want that to be? 7 meters, yeah? 7 meters. Now, to find the perimeter on this shape, we're going to find all the way around. All the way around. But there are 2 bits here that we do not know. But that's not to worry because we can work them out. We can work them out. And they often do that. See this left-hand side? From there to there is 7. And on the right hand side, from there top to the bottom is 10. So if that's 10 all the way from top to bottom and this bit's 7, this bit must be the difference between those two numbers. Therefore that has got to be 3. And the same can be said for this one. Now, if there to there is 5 and there to there is 8, then this bit here must be the difference between 8 and 5, which is again 3. Now to find the perimeter, you just add up all the numbers you've got. So 7 plus 3 plus 3 plus 5 plus 10 plus 8 equals all that added up together. So we've got 10, 13, 18, 28, 36 meters. There are other ways of doing this, but this is absolutely fine, this method. It's fairly simple, fairly straightforward, and you can't go wrong. But you can always go wrong, but it's easy as you can get with using this method. So you've got a bit taken out. So let's have a look at another one and go back to drawing the red ones. So let's do this way. Whoop. Like that sort of shape. So we could make that 8 meters, that 3 meters, that 2 meters, and that 10 meters, right? So now we've got different bits missing. We've got that bit missing and that bit missing. So to find the perimeter, we need to find these two bits. So let's go back to blue. To find this one here, it's 10 all the way across, and that bit is 2. So the difference between 10 and 2, this must be 8. It's nowhere near to scale, but this must be 8. Now, this one here, 8 from top to bottom. Well, we've got a little bit there, haven't we? A little bit there, 3. So this one here is the difference between the 3 and the 8, which is 5 meters. And 8 plus 10 plus 5 plus 8 plus 3 plus 2 will give you your answer. And it's 18, 23, 31, 34, 36 meters there. Yeah, I mean, these can be decibels. It's much the same thing. It's just a little bit more difficult. So let's have a look at some questions that are like this. So this one, what's the perimeter of the shape below? So we've got that 1.8. We've got the 3, 4, 3.6. So we've got a bit missing here, a bit missing there, and a bit missing there. So we've got 3 bits missing. Now, this one here is exactly the same as this one because there's no slopey lines. It's all lovely right angles. That's a symbol for a right angle in there. Look, yeah. So this one is going to be 1.8 centimeters. Yeah. This one here on the left. This one here on the left is exactly the same as this one here on the right. So this is going to be 3.6. So not too bad so far. Now what about this one at the top? Now all the way across, this one is 13.1, and we've got this bit here and this bit there. So that bit in the middle is the difference between these two added together and the whole width of the shape. So there's 7. So if we go 13.1 take away 7, what do you think that is? It's at 6.1. So this will be 6.1 centimeters. So we now have all the sides we want. So it's going to be 3.6 plus 3 plus 1.8 plus 6.1 plus 1.8 plus 4 plus 3.6 plus 30. Oh, can I go over there? 13.1. Right, so now it's time for the calculator, and because there are so many numbers, be careful. 3.6 plus 3 plus 1.8 plus 6.1 plus 1.8 plus 4 plus 3.6 plus 13.1. Right, I get that to be 43. I've made a mistake, let me know in the comments, but I get that to be 43 centimetres. The perimeter of the largest square on the right is 20. Now, there's something to know. Remember we said that a square, all the sides are the same. Now, if all the way around is 20, these four sides must be the same as each other. So if we do 20 divided by 4, they equal 5 centimeters. So each side is 5 centimeters. Oh, well, this is going to help. Oop. I haven't even read the question yet, and I've done all that. Yeah, so right. The smaller shaded square is removed. What is the perimeter of the shape that is left? Right, so it does help. So if that's 5 from top to bottom and this bit is 2, then this bit will be 3. It's a square, so that's 2 and that's 2. And this is 5 and this is 2 there, so this one again must be 3. So 5 plus 5 is 10, plus 3 is 13, plus 2 is 15, plus 2 is 17, plus 3 is 20. 20 centimeters. Now, don't be confused because the original shape was 20 as well. Well, of course it's the same, isn't it? Because what we've done, instead of going 2 and 2 going round the outside, we've gone 2 and 2, exactly the same. Yeah, so it's 20 centimeters. So the next bit is a triangle. So let's do some triangles. Now there's not too much you can do with perimeter of triangles. You can just be like bits missing or add them all up together. Now let's have a look. So we'll come on to this in more depth, but I'm going to, if you have a triangle and it's like that, and this is called a right angled triangle that we'll look at later because it's got a right angle in. If that's 3.8 and that's 4.9 and that is, I don't know, through the 9 or 16 or 5.1. Now, all those who study something called Pythagoras, don't shout at me because these numbers are made up, yeah. So, to find the perimeter of that, 3.8, 5.1, 4.9, we just all add them up together, don't we? So 10, 18, and 8, 9, 10, 11, 12, 13, 13.8, whatever it might be, centimetres. So if you've got all three lengths, you just add them together, the same as you do with a square or a rectangle. Now there is a triangle like this, and this is the triangular equivalent of a square, because these all sides are the same, and this is called an equilateral. An equilateral triangle where all the sides are the same, equal, they're all equal. So if we mark that one up as 10 centimeters and you want to find the perimeter of this, you know, because it's an equilateral triangle, and they'll tell you, they won't get you to guess, you know that the other two sides are going to be 10 as well. So that's going to be 10 plus 10 plus 10, which equals 30 centimeters. So you didn't have to work anything out. There's no nasty things. It's an equilateral. Oh, they're all the same. So that must be, the missing sides must be 10 as well. Here's the other one. Right, so we can have this is where two sides are the same, and this is called an isosceles triangle. Two sides are the same, and it will obviously be these two longer sides. So if you had that as 10 centimeters and you had that as 8 centimeters, I don't think that's to scale, but never mind, it doesn't matter. You've just got one missing side that you don't know, then you can think, it's an isosceles triangle. Thank you for telling me that. So therefore, this must also be 10 here as well. So it's 10 plus, 10 plus 8, which is 28 centimeters. Okay, 28 centimeters. Now, how can they dress this up a little bit different? Now, I'll do another isosceles triangle. A Greek word, I suppose, or the Mr. Isosceles discovered the triangle. Now, if I do this, and this is going to be in another lesson. It's all muddled up, this book, right? So a dashed line that goes through a shape is called a line of symmetry. You may have heard of the term symmetrical, is where one side is the same as the other. For example, a butterfly would have a line of symmetry going down through the middle because the left and right is the same, or a heart shape would be the same because the left and the right is the same. And wherever that left and right, imagine this was a triangle on a piece of paper and you folded it down the line of symmetry, the two sides would match. Yeah, they'd be exactly the same as each other. So this is called a line of symmetry. And this is telling you, because it has a line of symmetry, the left and the right are the same as each other. So it's an isosceles triangle. So if you have, that's 4 and that's 12. Now there's 4. Right. So the line of symmetry tells you that this side over here is going to be the same as the one on the left, therefore that's going to be 12, and this little bit here is going to be the same as that bit over there on the left, so that's going to be 4. So you've got, for the perimeter is 12 plus the 12 on the right hand side up there plus the 4 that we've got and the other 4 there. So that's 24 and 8, it's 32. Well, call it centimeters, yeah, it could be anything. Yeah, so a line of symmetry tells you it's an isosceles triangle. So let's have a look at some big questions here. What have we got? Right, work out the perimeter of these triangles. Well, this one's fairly easy. We just add the three numbers up together. So 2 plus 2 plus 4 equals 8 centimeters. Work out the perimeter of this one, where we just add these up together. And I'll go 2.5, 6.5, and 5.0, just to keep things tidy. 5 and 5 are 10. Don't forget the dot. 2, 8, 13, 14. So 14 centimeters. What's the perimeter of the, look, equilateral triangle on the right. Now, because it's equilateral, all three are the same. So that must be 3, that must be 3. So 3 plus 3 plus 3, I think that might be 9 centimeters. A line of symmetry has been drawn on the triangle on the left. There, that way round. What's the perimeter of this triangle? Now, the line of symmetry tells us that it is a isosceles triangle. Therefore, that must be 7 down there, and this bit must be the same as that, so that's 2. So we've got 7 plus 7 plus 2 plus 2, which is 14, 16, 18 centimeters. Yeah, okay, so square shapes and triangle shapes. So there'll be a worksheet on this, and I'll see you in the next one, where I think we're going to move on to circles.